No, guys, I have to talk. I guess I'll use the mic as well. Informed on what's happening with Explore, and then we're going to go ahead and get started. So the first thing I'm going to have you guys, I guess, pay attention to, the first thing I'm going to highlight is our Explore Hub. So go.fiu.edu/Explore Hub. Remember, this is where you can go to see all of our live streams, to see all of our resources for the different workshops. If you guys missed one, if you guys fell behind, you will have everything on that Explore Hub ready for you guys to take a second look if need be. I encourage you guys to go there if this is your first hardware workshop, and make sure that you guys download your Arduino IDE. And I think that's the only thing that they need essentially for that. Yeah, so just make sure you have your Arduino IDE installed so you guys can go ahead and code along with us for the projects. So we're actually going to be announcing the opening of cohort 2 today. So I'm going to go over a little bit of how the cohorts work again, although I think most of you guys are familiar faces, you should have an idea. But essentially, we're doing Explore a little bit differently this year. We're doing a cohort style. So even though our workshops are still always open to all students, FIU or not, you guys are going to sign up for particular cohorts for particular tracks. So we have our web dev, game dev, AI, and hardware. So our first cohort has essentially already ended, so you can no longer sign up for these workshops before spring break. But all of our tracks are going to repeat now after spring break. They're going to be the same preliminary content and same foundations, but different projects. So if you guys want to go ahead and revisit a track, you'll still get that foundational knowledge, but you'll have another project under your belt. And if you want to try something new, I encourage you guys to, so that you guys can kind of dip your toes in all different areas of CS and see what you want to do. So our cohort 2 is actually opening today. Can you open up that toggle? If you guys want to sign up for 2 different tracks for the next cohort, which starts after spring break, please fill out this form now. This is also going to be on our Discord, on our socials. Remember that we also have our Explore Hub on the Discord, so if you guys want this link or need any more info, I'm always there answering questions. And again, we're going to be posting it on social media, and you'll see it around. But if you guys are interested in joining any of the tracks, again, it's web dev, game dev, AI, or hardware, for after spring break, then please go ahead and scan now. I'll give you guys a few seconds. And like I said, you guys can join the same ones that you've already participated in if you want to get the same foundation with a different project, or you can try out a new one. These are going to be open for a while because after spring break, we're going to start with our intro workshops as always. So probably web dev will be the first one, and that won't close until like the second week after spring break. So you guys will have some time to figure out what it is that you want to do. So I'm going to skip this for now. If you guys need this link, I believe it's also a Go link, go.fiu.edu/initexplore, or just message me on the Discord, check out the Discord announcements, whatever. So now I'm going to go over some of our upcoming events really quick, which we only have one, essentially, if you can scroll down. We have our last AI workshop on Wednesday at 4 p.m. in PG5 134. I'll update that. All that information is also on the Explore Hub, and you'll see it on our socials as well. And if you guys are part of the AI track, please make sure, please make sure to go to this workshop, especially if you've attended the other 2 cohort workshops, because you guys will have a chance to get your Explore merch, and you'll be able to fill out that exit survey so that we can get feedback on how we're doing and what we can improve. So if you guys are interested, scan this now, but again, you'll have a chance to do so later. That's basically all I had. I'm going to hand it over to Mr. Franco. Thank you, guys.
stickers?
I brought candy. I'll grab stickers.
Yeah. Yeah, please. Can we put this?
Oh, should be clipped.
Oh, yeah. Never mind.
There you go.
All right, welcome everybody. Back again to the second workshop of this cohort series. Thank you all for coming. Honestly, guys, I'm very impressed with the process that we made so far. I'm very happy that I saw a lot of traffic lights shining the other day, and so it was a great project to put all the things that we learned so far together, and it's a good sign that we are improving, and I hope that this pace keeps up. So we have a long way to go today to reach the final workshop on the first Monday after spring break, where we're gonna be doing very fancy projects, but we still need to incorporate some final foundational concepts in order to get to that workshop in the best possible conditions. So everyone checked in? Yes? Okay, great. So quickly for the agenda, well, the announcements made by Nicole. We're going to be doing a recap of digital signals and PWM, which we already saw in the previous workshop, but still, as we are going to build on top of it, it's not that we're going to forget something and pretend it does not exist. Like, we need to incorporate it and add the things that we're going to learn today. That's the one thing. The digital input. So today is a very important day because we're going to be actually making the robot interact with us particularly. Well, in reality, the robot not only with humans, but with the environment itself, with a lot of situations. And we're going to hopefully make the robot drive to some, to make it do some statements through our code based on the input that our components read. So that's the one thing that we're going to be doing with digital input. We're going to be covering serial communication, which we're going to see in some minutes, analog signals and analog pins, as we saw digital and for digital pins and digital signals, the same way with analog, which we're going to be doing. And finally, well, mini projects and hopefully doing a lot of things. So, well, as I just said, today is human-robot interaction workshop. We're going to be, it's very important because we're going to be using input components that serve as input to hopefully drive to some instructions and make the robot do something for us. It's not just that we're going to be, like in the previous workshop, if you guys remember, that the instructions that we passed, it just was pure mere static code. But now we're going to be introducing the environment, so that's a crucial thing. So, quick recap about Arduino and the digital pins. So my question is, does anybody remember what values did the digital pins take for output to turn on an LED? Five is the voltage, yeah, but in terms of Arduino IDE, what were the parameters? High or low, right. So that's the first thing, as we saw, like we can either turn on a light at its brightest state, passing it a high argument, which is it's translated as 5 volts in electricity, and the other way we can do it with low, and it's not going to read any signals, right? It's going to be 0 volts, and that's what we use for output. But now we're going to be using digital also for input that we're going to see in some minutes. So yeah, and the pins that we're going to be using, again, the 2 to 13 for the digital pins. And also pulse width modulation, PWM. Does anybody remember what it did from last workshop that we used, particularly with the traffic light? With the fade in and the fade out of the yellow light. Remember what it did? Any ideas? Yep. Perfect. It takes a continuous amount of voltage in terms of electricity, and in the Arduino IDE, as you can see in the PowerPoint, we can pass it through the analog right from 2 to 15 to 255, including. So being 0 the lowest and 255 the highest power, but we could pass any argument in between that range. Remember that it's a continuous voltage levels. Great, thank you. And again, we're going to be using the analog write for this. Well, that's a recap about the previous one, but again, we're going to be using it not only this workshop, but probably if you want to delve more into robotics, you're going to see it very, very often. So keep that in mind. Well, first topic of the day, we're going to be using digital input. And again, the same way that we did for output, where it was either 0 or 1, or 0 volts or 5 volts, right? On and off, like they're all synonyms, but in different contexts, they mean different things. Again, the digital input, the components that we're going to be using, we're going to read either ones or zeros on Arduino IDE, and we're going to do some things based on if it's turned on or turned off. And two good examples about digital input. So we have push buttons and also switches. So for example, if you see how we turn on or switch on the light, it's basically doing that. It's probably using digital signaling, and it's binary. It's either turn off or turn on, and that's what we're going to be doing first today. So an important topic. So as I just said, like in the digital input, a very good example is the push buttons. And if you guys saw, for example, when you turn on your laptop, when you turn on your cell phone, anything, including the robots, you can see that you either turn it on or turn it off, right? And just that's a basic digital signal they're going to be doing. And the way that it works, for at least in the Arduino board that we're going to be using, as you can see in the diagram, let me see if I can use the laser of the PowerPoint. So as you can see, this would mimic our Arduino board, right? Here we have our digital pins from 2 to 13. Remember that the digital ones are from 2 to 13, including. And in the case of the push buttons that we're going to see in some minutes, and we're going to be doing the wiring in the Arduino, you can see that there is a diagram, right? It's a circuit. The buttons will have, as always, one connection from the ground, which is basically the negative charge battery, or it's going to read 0 volts. And we're going to start using, as you saw, for example, in the previous one, remember that the LED was directly powered from the digital pins, that we just needed like connect the longest leg to the pin, to the digital pin, and the short leg connected to the resistor and then to the leg. So there's no external supply there, but that's because the LED works under very low energy consumption. But in this case, we're going to start using more complex components, and therefore they're going to need more battery. In this case, we're going to be using the external source, which is 5 volts, but that is, it's not external. It is embedded in the Arduino board for us, right? But we're going to be using specifically, that we're going to see now, the 5-volt pin, the ground pin, and as you can see here, this thing is basically saying, okay, it's restricting the current, the energy flowing, so that we don't burn either the button or the pins. And here, as you can see, there is a kind of gate. Can anyone tell me what this could be? Exactly. That's going to be our switch or our button. And if you think it in terms of what it's doing with the energy, it's not that the button is smart or sending us, okay, this is turn on or turn off. What it's doing is restricting the current from flowing or allowing it. So in this case, you can see that by default, this is the diagram when the button is not pressed, meaning you see that the gate is open. So this means that this is our pin 2, this is our ground, right? And we only have the pin 2 will only read, for now, in this current state, ground values. Why? Can anyone tell me why it's going to read only the ground? Which is translated into 0. Why? What the button does here. Any ideas of why? Come on, guys, I have some stickers for you here. If you answer it right, I can give you 1 sticker. No ideas? Nothing? Come on. I need one answer, and I move on. Anything. Give it a try. What? Can you say the question again? So, this is our digital pin 2, right? So our digital pin 2 is going to be connected to our button, to our switch, which is here. But with the current state of this diagram, is going only to read values from the ground, which is basically no energy. Why? Just by looking at the wires. Exactly. So our gate is open, meaning the energy is going to try to jump to the other side, but it's not open. It's not closed. It's open, so it's not going to reach this 5-volt energy, right? And once it does, once we press our button, this gate, which is our button, is going to close, and the 5-volt energy is going to flow, and this is 0 volts. It's nothing. But once we have the 5 volt, our pin number 2 is going to read 5 volts as input. So it's going to say, okay, someone is definitely pressing the button, right? So that's what we're going to be doing. And here, it acts as a closed or open gate, which we already saw. And there are 2 different ways of implementing it. And this is very important, guys, in the world of push buttons and digital signaling. We are going to be using a 10K resistor ohms, right? That's what it does to prevent not only the button to fail, but also to protect our Arduino. That's the first thing. And definitely, we have 2 different ways of implementing it. We have the pull down or pull up resistors, which is, I don't want to delve too much into it because we might get confused. But if you saw here, we can see that we have a 10K resistor that is connected to our ground. And as in this current state, basically the circuit is just doing this, right? Doing this because this is open, as you said very right. Let me give you one sticker because I forgot. So guys, if you participate, it doesn't have to be okay, but I give you one sticker. So keep it up. So as I said, this circuit is gonna be flowing just like this. This is open. The 5 volt is, hanging around. It's not reaching anything. It's reading 0, 0, 0, 0. Why? This is not open. But the resistor here, this is called a pull-down resistor. Why? Because it's driving the negative charge pole, the negative charge energy, the ground, or 0 volts. There's another implementation where the resistor could be restricting the 5 volt energy and directly connected to our pin, to our number 2 pin. So instead of connected to our ground, it's going to be connected to, oh my God, this is ugly. It's going to connect it to the to the pin number 2. It's going to be restricting the 5 volt pin, but in this case, it's going to be the other way around. It's going to be the opposite way. Instead of reading 0 volts, because now it's reading 0 volts because it's connected to our ground, the other way is called a pull-up resistor, which our pin 2 is going to be constantly reading 5 volts instead of 0 volts. Because although the gate might be open, the resistor is going to be in the other side, and it's going to be so this would be connected like this, basically. To try to mimic it, this is going to be our resistor, right? Kind of ugly, but it's fine. And this is going to connect. Forget about this. Like this, we don't want it anymore. We're going to have this, and it's going to be connected to this thing. And then here we have our switch, right? Which is going to be connected to our ground. So when the button is not pressed, it's going to read 5 volts. When it's pressed, it's going to be 0 volts. So it's the opposite way, but it's good to know that there are different ways of coming up with the circuit. And diving more into this, now I don't want you guys to to not wire it now, but we're going to be doing in some minutes. But as you can see here, which reflects the same thing in the diagram. Here, this is the buttons that we're going to be using. They're very tiny ones. So it might be difficult to find it in the kit. But if you need help, please let me know after. So remember, we're going to be using this resistor. It's a 10K ohms resistor. There's, in contrast to the LED, there's no positive or negative charge for the button, at least. You can connect it either way. But what we need to make sure is that our pin, our digital pin, for example, this little number 3, is going to be connected into one side of the button, and the resistor is going to be connected in the opposite leg, in this case this leg, connected to this resistor that is going to be connected at the same time with our ground pin of the Arduino. And we're going to close the circuit the other way in this side with the 5-volt pin connected to a different column of the bottom. And what is very important here to understand how the energy flows, how this gate works with electricity, is that, as you see, this is the state of the button pressed, right? As you can see there in green. I don't know if I can erase this. As you can see here in this left image, we can see that the button is currently pressed, right? This is the state, which means that all the legs, the 4 legs, are going to be interacting with each other, meaning if there is any leg that is connected to 5 volts, it's going to read definitely 5 volts. Because the other legs are going to be 0 volts. We are not going to have a saturation of electricity or something. But in contrast to this state, we have the gate open, which is when it's not pressed. And you can see that instead of the energy flowing into the 4 legs, the energy is going to flow only up like this side. This like 2 legs, right? The vertically, that is going to flow vertically, meaning these legs. And separately, these 2 legs. So, for example, the pin 3 here is connected to the right leg of the button, this leg, right? This leg. It's going to read values in this, everything that is in this column. And in this case, what is reading? What is going to read? If it's connected in this row, in this column, and the energy flows vertically. Just by looking at this diagram. What is going to read? 0 or 1? 0. Can anyone tell me why?
Because there is a resistor. It's the same point of where the resistor is.
The resistor, but here the resistor is not telling exactly that it's going to be negative. What is telling us that it's going to be negative charge?
It's connected to the ground.
It's connected to the ground, yeah. Great. So yeah, I'm gonna give you guys stickers in some minutes. But yeah, so by default, when it's not pressed, because we are doing a pull down resistor implementation, meaning that the resistor is gonna be fed with negative charge electricity, and by default our pin, if it's not pressed, is gonna be flowing only this. We can forget about this red wire and the left part of the button, because our pin is connected to this row, and we are interested in whatever is connected in this row. So in this case, connected by default, negative charge. Can you guys see it clear? It's clear enough? Yeah? Let me know if you have any question, because this topic might be a little bit more difficult. So this is the pull down resistor. And another thing we're going to be using now that we're going to start interacting with the robot, and we're going to be like seeing what kind of data is reading, and probably we're going to be testing what is going on with the component, because in real world, when we have many components in the same robot system, we want to make sure that first all the components are working properly, but also that we have all the expected values in our code, right? So a good thing in the Arduino IDE provides for us is the serial monitor or serial communication, but by definition, it's just the communication between our Arduino board and the computer, right? And it's widely used for testing, debugging, visualizing what is going on with our variables. If you guys remember that we pass 0 or 1 to the LED, you can check what value we are passing in the monitor. For those that are Java programmers, it could be the same as a console, right? But in robotics, we call it a serial monitor. And the serial port, I'm going to drink some water. Oh, wow. Okay. And a serial port is basically where the physical connection takes place. We don't want to, it's not that much science. And definitely in the Arduino IDE and for our code, we're going to be using two main functions. The first one, which is built in, is the serial.begin. And the baud rate, you can see the first argument is basically the frequency, right? The same port can connect to different frequencies. And we don't know, we don't need to know what that means now, but it's basically we're specifying, okay, listen to this port and these two particular frequency and read values from it. And the serial println is going to print data to the monitor, basically. We're going to show what's going on. So now, the mini project. So I want you guys to, we're going to get started with the digital input. Let's stop the lecture for now so I can drink water. No, I'm kidding. But we're going to start with the project one. I want you guys to start wiring. I'm going to now first hand in, if anyone can help me with the, please, Victor. If you can hand it in. So Victor is going to be handing in the Arduino kits for me. Thank you, Victor. Well, you deserve the sticker. You did.
Okay, thank you, thank you.
And these guys too, because they're participating a lot. I appreciate it.
Thank you.
I don't know if I forget someone, but so once you get your Arduino kits, I'm gonna explain what we're gonna do.
The kid's gotta wait, porque ahora tengo que escoger dónde lo pongo. ¿Ves? Es más difícil.
Whatever you want, man.
Whatever I want.
Whatever.
Damn, dude.
Yo, I want the sticker too.
I'm sorry. No, you have to participate.
He stole my answer.
No, but you have to do like 3 in a row. 3 in a row. Yeah.
As soon as I saw that you were giving stickers, I was like, oh, the next one's for me. And he stole my answer. I was so mad. I was so mad.
Yeah, I saw you. I saw you. At least I saw the intentions.
Yes.
Everybody has it? No, not yet. No. There are any? You need more kits? Yep. Hey, let's see if there's.
I mean, I don't know how many you guys have, so.
Okay.
and there are people that are missing components. But now I Exacto. Thank you.
Ok, ¿tú qué tal? Pues bien, ahorita estoy haciendo este proyecto, un programa que se llama Memorias. ¿Verdad? Estamos armando un rover, really fucking cool experiment. Yeah. Pero ese que es un proyecto de hydroponics.
Guys, and make sure it's connected to pin 2 of the Arduino, the digital pin 2 for the upper part.
He estado poniendo unas pruebas en el laboratorio para que el proyecto funcione. El proyecto es armar una robot de estos que van a la luna. Y entonces, adelante tiene unos campos que son simulacros
Congratulations, man.
Oh, thank you. Sí, ¿verdad? ¿Has estado perdido? ¿Has estado trabajando? ¿O qué estás haciendo ahorita?
Clase, obviamente, luego sí trabajo, pero propio.
El señor Santos Enterprises.
Claro. Y lo demás, ahí nomás, no, quería hacer
¿Estás haciendo ahorita?
por eso me metí acá.
¿Qué emoción quieres vivir, chico?
No,
Let me put this.
You know what we should do before next semester? We should go through the kits and make sure.
Yeah, definitely. But for now, it's. How is the wiring going? It should look something like that. I tried to use both blue wires for the ground and both orange wires for the 5 volts, so you don't get confused. And the green wire is connected to the digital pin 2.
This project too, right?
What?
This project.
Project 1.
no, it's not gonna break.
Because if it was mine, I would do the things that.
Oh man, don't worry.
Yeah.
You guys finished with the wiring? Yeah? Okay, let's move on to the code. So I want you to open the Arduino IDE and start typing that code. So I'm gonna show how to create a new sketch, but there is no code that I loaded for this because I want you to actually type it. There are just a few lines. And then we're gonna go over it and when you finish. So open your Arduino IDE and start typing that code that we're gonna see what it does. So in case you don't know how to open a new project, so you need to go to your Arduino IDE. You go to File, New Sketch, and boom, that's it. And then you start typing your code, and then when you save it, you can assign the name that you want, but Workshop 2 Project 1 would be good. Let me know how that goes. Oops. My bad. No worries, student. Let me know when you finish. Whoosh. Did you guys finish with the code? Not yet? Okay. I'll give 1 more minute.
Damn, he's fast.
It's just a old project that I did.
Oh yeah, something like pass the time. Nothing crazy.
Finish with the code? No, not yet? But any problems or just typing? Okay, okay.
¿Fuiste a jugar voleibol?
All right, everyone finished the code?
Yes, sir.
Yes? Everyone there? Okay, there too? Okay, great. So, let me put the... Okay, so diving into the code, what it's doing. So, as usual, at the top, we define all the variables that we're going to use. In this case, we introduce a new keyword for defining variables, which is a constant, or the const, in this case, for the C++ syntax, which is saying, okay, this variable, we know for sure it's not going to change in the logic of a robot, right? And that's great to keep in mind, because when we will have like many variables in the real world, we want to make sure that for the things that don't change, the developers that do all the stuff, that usually sometimes someone builds something on top of what other people did, and it's a good thing to do, because it's not gonna, if you don't use it, it's gonna work the same way, but it's a good practice. So here we define the variables that won't change. Basically, in this case, just one for the pin. We are not gonna keep changing the pin of the button. It would be a disaster for a robot. And in the case of the variables that will change, in this case, we wanna keep track which is the state of the button, whether it's gonna be on or off, open and close, as we saw in the diagrams. So that's everything. As usual, the void setup and the void loop. And here we will introduce two new concepts. So you're gonna be doing digital read to read the input from the button. And also we're gonna start using the serial monitor, which is very, very important, guys, to debug all our applications. And it's not only for robotics, but in general, in programming, in software, it's a very, very good practice. So in the setup, we need to define, in the case of our serial communication, by saying serial.begin, and as we see here, we see that this is the baud rate, this is the frequency of the port that's gonna read. Now I'm gonna show you how we can open the console to that frequency, and we're gonna be reading values. And here we're just saying, okay, the same way that we did for the LEDs, where we said the pin of the LED, comma, output, the same way we're gonna say, okay, in this case we have a bottom pin, 2, comma, we're gonna be using it as input. So that's gonna be our 2-line setup, pretty basic. And then in our void loop, which is our logic, same, that doesn't change from project to project. We're gonna be storing, in this case, we define here above the button state. Remember that all the variables is a good practice to put it at the top of the sketch of the Arduino. But it's not gonna be 0 all the time. Here we're gonna be reading, okay, please Arduino, read what's going on with electricity flowing through our button. Is it open or closed? Is it turned on or off? So this is gonna be changing from 0 to 1 and vice versa, right? So you're gonna see that if we press the button, this is gonna become 1 or high, and if we don't press it, it's gonna be 0. And if you keep pressed, of course, if you keep it like pressed, it's gonna be 1 the entire time. And then, as a debugging, we're gonna test whether our input is working fine, properly as expected. Through serial.println, we're gonna be printing like new lines for all the values that we're gonna read, similar to what happens with console.out.println for the Java programmers. And so let's actually run the code. Oh, thank you. That's a good one. So if please open your Arduino IDEs again. I guess you have it open. No, not this. Wait. This? Okay. So I'm gonna connect my Arduino as well here to my computer. Please, everyone, do it and compile the code, clicking the arrow as we saw in the previous workshops. We're gonna see what's going on behind the scenes with the values of our button. So we compile it. Any errors, guys? I hope no. Compiling, success. Was a success or no? Yeah? Yeah? Okay. So we are not gonna have like any visual feedback for the robot. We don't have any LED, but you're gonna start learning what is going on with the digital input. In this case, we're storing the value of what's going on with the bottom, if it's open or a closed gate, if it's our 5 volt is flowing through our button or not, and reaching our pin. And depending if it's closed or open, as we saw in the diagram, then our pin is gonna read 5 volts or 0 volts, or zeros or ones. So what we need to do now, please follow my arrow in the computer. So we're gonna touch this little thing, this icon. It says literally serial monitor. So click on it. And you can see there's a whole bunch of zeros traveling at the speed of light, basically. Like, it's difficult to keep track of the values. You guys see zeros being printed out? Great. Try now to press your button and see what's going on in the console, in the monitor. What's going on? There's a 1. Nice. then we are going through in a good path. You see once? If not, then there might be an error with the wiring or the code, or probably with the wiring. You guys see it's 1 or 0 when you press it? There. 1. Everyone got 1 when you press it? Just making sure that all the circuits are fine? Okay. You got 1? Guys, you got 1 there? Huh? Which?
Before pressing it, it's like sometimes 0, sometimes 1.
Check, because it might be a problem with the circuit. It should be like stabilized in 0 when when not pressing.
It's fine now.
Yeah?
Maybe the bottom base.
Maybe.
So it has memory. I did a Simon
Okay, so now we saw that it's working, but generally what happens in real life is that a button might cost not too much at least, but when we are dealing with motors of the vehicles and everything, we don't want to spend $100,000 because our code is not working. So what you should do first, and that's where the serial comes into play, is to debug it. See what values it's reading before committing changes to the hardware itself. So it's a good practice first to filter and see what's going on in the software, and then testing the hardware, because it might be a misfunctioning of the hardware component itself or a problem on your end with the wiring. So that's a good thing to keep in mind. So moving to project number 2. So now we're going to start interacting with the input, both input and output. So if you guys can please, I don't want you guys first, it's to mention this, don't get confused, because there are like 2 Arduino, oh, there's no. Project number 2, now yes, it should be. Yeah, so as you can see in the diagram, we have 2 breadboards, but because I couldn't find a breadboard that had both an LED and a button, but you don't need to change the button at all, just keep it as it is. Just add 1 LED as you learned in the previous workshop, remembering that we're going to be using a 220 ohms resistor in this case. And please make sure you connect the LED to pin number 3, which is PWM capable, that we're going to be using afterwards. The button, you don't touch it, you just add an LED to pin number 3 using a 220 ohms resistor as described in the instructions. And as you see as we did in that button, that we fit in the positive, the 5 volts, and the negative. So we are not using the 5 volts at all with the LED because we are gonna burn it. We don't need an external source. It's enough with the power that triggers the digital pin. And it's the longest leg. Remember that it goes with the LED on the resistor, with the pin number 3 on the resistor, and the ground, it could be connected to the row where you had connected before the bottom.
No, I know. I mean,
Oh yeah.
Do
Yeah.
we keep everything that we have and just like add this to the side? Or what?
Exactly.
Okay, word. Because this uses a different resistor.
A 220. Exactly.
Big brain.
Let me see. How are you, bro? Good? How's it going? Doing well, I see.
So
Yeah.
place this with the 220. We just did that, and then.
Oh,
you
wait.
wanted us to
You don't touch the bottom,
No, no,
No,
the
we-
resistor.
the resistor.
We don't.
The
touch
resistor. Okay. This is a 10K, right?
No, we switched it to the.
220.
You shouldn't. You shouldn't change.
No, the 10K. Oh yeah.
It says a 10K? Yeah. The button, you don't touch it
But you said 220 resistor for the LED.
for the LED.
Resistor for the bottom.
Right. The 10K, as before, is sorry, for the button is 10K, and this is a 220.
Okay.
Different.
So do you have both, right?
Let me know. Do you know if I'm muted or not? Because the light One table. What about the others?
You could at least like
Finish it or not?
finish the degree with like Internet of Things and electrical.
You guys did it.
Because for IoT,
I think they didn't, but. Yep. It's fine. I want a volunteer to tell me what was your idea? The code. Let's type it. Let me see. Any volunteer? Any ideas how to implement it? You're gonna be typing it. Anybody? Okay. You tell me and I type. Yeah. Come. Do you want to write it? Type it. Let's see.
So if, okay, well, it's in capital. If, and then button state equals time, all capitals.
In capitals.
You need our little, one of these, and then we'll do, what's it called again? Digital
Right. Right.
Right.
Victor, could you?
LED pin.
You could connect it? It works? Check the resistor. It's a 220. Try another LED.
Digital right. Is it lower or off?
Low. Great. Let's try. Thank you.
Hopefully it works.
Hopefully you don't burn my Arduino, but well, let me see. So I'm gonna compile it blindly. I don't know what's going on. Let me see. It did blow up. Okay.
Well, the makers don't have classes. Some of them are going to.
Here's all the classes that we had before.
Great. It's working. All right, so could everyone make it work, the project number 2? Yeah? Great. Okay. So moving on to the next one, it's kind of similar, but it gets a little bit trickier, the logic, because it's the same circuit. You don't need to change the hardware. We're going to play a little bit more with the software. But in this case, I want to simulate the behavior of a light, right? You just switch it on, and it should remain switch on. It's not just when you press it, it's on, and vice versa. You switch it on, you press it, you switch it on. If it's switched on, and you press it, then switch it off, right? Same behavior as a light switch. And you can see in the to-do, the code is the same, and there is just a delay of 25 milliseconds, because 75 milliseconds, because when you press it, C++ runs so fast that it might read 2 high values in a matter of seconds. So it's to not avoid repeated readings. So the to-do is there, and we just need to implement it. Let's do the same, and then we find another implementation for this. So it should be pretty similar, but it changes a little bit.
It's good to know. I really want to check that
Oh, by the way, let me upload in the Explorer Hub.
have to make half an hour presentation. I have videos of me that are like 45 minutes presenting a PowerPoint. About what? About, let me show you. I might have in my notes here, like a sketch of when I was presenting for that class. Because it did last year.
And another one that I definitely want to take is the operating systems.
Operating system should be going. Like if you want to get into Linux,
Yeah, that's something that I'm really kind of weak.
So if you visit now the Explorer Hub, you should find in the drop-down the same file, project number 3.
yeah, you get to see like how all
Let me know if it shows up.
commands work, right, and how to use them together to create pipelines for that.
Could you find the file? Yes?
This is my script. Like, this is just like me saying the steps and shit. I don't have like the information because I'm at the part that I like to present it, right? So I really
So there are different ways of implementing the logic in this one. Anything that completes the tasks is fine. Then we can share it.
and then we have, for example, I have a Raspberry Pi. So the Raspberry Pi and then work as a server and which is great. However, the way it works is that the professor gives you the code, right? And the code is full of bugs.
Oh, and I forgot to point out that there is a new variable, let state,
That's how the class works.
because as we want to keep it switch on or switch off, we need to make sure that there's a fixed variable that we're going to be changing based on if we press a button or no. That's going to change.
Do you learn some kind of like hacking?
Doesn't?
Like I changed the resistor, I changed the LED.
Oh, you change the LED and doesn't work? You already implemented this? You may have an error in the code. No?
Just with another LED, like it worked. Like it not work, but it turned on, but like so low. Like the light was so low.
Ya sé cuál es el error.
Okay. Which one?
Ah, no, mentira, no.
The
Hardware.
wait, this is working, right? The button
¿Lo
is
pusiste?
reading.
¿En qué puerto lo pusiste?
Let me see. Bro, you abandoned the ship.
It started with the fucking Simon Says game,
Yeah,
and after it was downhill for me.
it's fine though.
Now we are have some professional talk.
Literally.
Business talk.
Project 2. Workshop 2.
Are you doing any other tracks for the inlet or just the hardware?
Just the hardware. Yeah, I was gonna do the AI hardware, right? As I told you.
But I think you were saying that I really like the second one that I had. I did a tic-tac-toe.
Okay, so this is what the code should look like. You might have slightly different implementations. If you guys did something else, you are free to share it. But basically what we are doing here is we didn't touch this. This is going to change to 1 or 0, right? It's going to be 0 or 1. We print it for you to see in the console. And here we have two variables, right? The button state and the LED state. And both are turned off at the beginning. We are saying the first if, always there's going to be a change whenever the button is pressed. We don't want to change anything about the LED if the button is not pressed. So this will remain constant in both if and else if, right? The only thing that's going to change is our second part, which is this one. If it's pressed and with this operator, the LED state is the LED is off, then we put it high. If the button is pressed and our LED is turned on, we turn it off. And then we call just once digital write the LED pin, which I already defined here, which is 3, so make sure that you have it connected to your pin number 3 in your Arduino. And we are just passing as a second argument LED state, which is going to be either high or low from our if-else statement. And then there is a short delay of 75 milliseconds to avoid repeating same readings from the button, because it runs so fast that it might turn on and off very quickly. So try to copy this code, and if your hardware is fine, it should work.
No, that I don't have to connect to my computer. Oh, but that's for the breadboard, right?
Yeah, if you want to keep using the breadboard.
Oh no, but I'm powering up with the Arduino.
By the way, you need to press your button real quick. But if you want to do it slower, you can increase this number maybe to 150 or something.
never ends. Boom, sick. All the way to the top. God. Here what we have is that here we should have a Arduino Nano connected over here, right? But we took it out.
Oh, okay.
Yeah, it should be there. The same thing. And then we have four H drives, which are these
Oh, I know.
like,
It's like
to control DC motors, yeah, high current motors, which are these.
No, but actually yes, but I mean it's time, but yeah, I don't know if I have to, but did it work now?
Those are the motors.
Yep.
And then, yeah, that's the whole
Did it work over there? Yep, nice working. So if you keep it pressed, you can see that it's gonna blink forever, right? Can anyone tell me why it's gonna blink forever?
yeah, which Arduino has.
No?
We need like 40
You wanna give it a try? Why it's gonna blink if you keep it like pushed? Why? Yeah, sort of, yeah. So it's gonna keep changing from 0 to 1, 0 to 1, 0 to 1 all the time. So that's why you put this delay function here, and the bigger the number it is, the like it's gonna blink less, but also it might not read some signals. So that's you should implement it very carefully.
So basically,
Was that some kind of
no, it's a project. No, it's just a project.
Oh, just for
yeah,
fun.
there's well, there's. It's
Oh,
called
was it for
Robotics.
the club? Oh, okay.
Yeah, Robotics. So it's a prompt and answer. And then we have the 4 wheels. We control them with an excavator controller, right? And then the idea is to have an excavator so we can dig at these 50 centimeters. Collect the regolith, I think it's called.
Thank you.
last project we did? Yep, okay. So I see it's already 6 o'clock, so if you can guys start to pack it up, and all the Arduino kids, please. And actually today we ran out of time. I had another topic that I wanted to explain, but for sure we're gonna cover it in the final workshop before doing the projects, and we're gonna be over it like very. We're gonna do another project in the next workshop. Actually, many fancy projects, and we're gonna actually start using not only. Yep. What's it? No, don't worry. Yeah, good question. So the last workshop of this first cohort is gonna be not next Monday because it's spring break. The other one, the first Monday after spring break. So, yeah. Bye-bye. So thank you guys for coming, and hope you have a wonderful spring break, and hope to see you the Monday after that we're going to start using all the sensors and everything. So we're going to have fun. See you guys. Thank you.